Today we're looking at trigonometric ratios and right triangles. So here's how we're going to go about solving these things. So solving our trigonometric ratios, first thing we're going to do is we're going to make ourselves a proportion. Here it says we're going to cross multiply. Basically we're going to go solve our proportion. And we'll have to do some dividing here. So the first one here says we have the sine of 30 degrees is equal to x over 12. So my goal is to get the x by itself. So technically what I'm doing is I'm multiplying both sides of my equation by 12. So I now have 12 times the sine of 30. This tells me what the value of my x is. At this point I can go grab my handy dandy calculator here. I got my calculator, let's turn it on. It doesn't work if it's not turned on. Hey, there we go. Turned on. And we go over here and we hit, well, first, before we do anything, always check the mode. Make sure your calculator is in degree mode. And degree is highlighted. It is in degrees. So now I hit 12 sine 30 and press enter. And I find out that x is equal to 6. Looking at example B here. In example B, my goal is to get the x by itself, so before I can do that, I have to get it out of the denominator. So I'm going to start off with multiplying both sides by x. And in doing so, these x's cancel each other out. I now have x times the cosine of 42 is equal to 15. Now I can go and isolate the x by dividing both sides by the cosine of 42. And at this point now I can get my handy dandy calculator and go and find out what value that is. So I go grab my calculator. So I'm doing 15 divided by the cosine of 42. Press enter. And here I have 20.2. 20 and 2/10. Once we have it set up here, it's a matter of grabbing our calculator and plugging the values in. Looking at C. C says the sine of 82 degrees is equal to x over 3. Well, my goal is to get the x by itself, so I'm going to eliminate the fraction by multiplying both sides by 3. Doing so, these 3's cancel here, and I have 3 times the sine of 82 is equal to my x. So x is equal to, well, let's go grab my calculator again, pull this over so we can actually see what's going on. Here, I do 3 sine 82, press enter, and here I'm going to have 3.0. I put 3.0 to let people know that I actually rounded that to 3. It was not 3 exactly, with the value being 2.97. Moving along here. This next part here says, remember that our sine is equal to the opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is opposite over adjacent. Here is the value, here is my angle A right here. So it says, hey, let's go label these things. Well, the opposite, this will be my opposite side. This is my adjacent side. And this is the hypotenuse. We're going to be using these things to actually help us solve and find missing pieces of right triangles. So looking at our next example here, it says find the missing measurements. So I'm looking for this value of x right here. I have the values of each of my angles, so I can use either sine or cosine. It doesn't matter which one. Let's use this angle right here. So if I'm using this one, that's going to be the opposite side. So that's going to be my sine of 21 degrees is equal to x, the opposite side, over 9. 9 is my hypotenuse. Now I need to go and solve it like I was doing those first couple of examples. Multiply both sides by 9. So I have 9 sine 21 is equal to x. Grab my handy dandy calculator right here. I go back in. There we go. And I press 9 sine 21. Hit enter. And I see that the x value is going to be 3.2. If I were to do the same thing using my cosine would have been the cosine of 21 is equal to x over 9. So I would have to do 9 cosine 21. We should get the same answer. So I press 9 cosine, oh wait a minute, not 21, it's a different angle this time. It would be this angle, so instead of 21 it would be 69. So I would have cosine of 69 degrees. Because I'm looking for this value right here to still give me my x. So the cosine of 69 degrees, and again, it's still going to be 3.2. You'll get the same value whether you use sine or cosine, paying attention to which one is the connected and which one is the opposite, unlike I did to start with. Looking at our next one here, I'm looking for my value of my x right here. So this time, let's start off, let's do the cosine. So I'm going to use this 37 of 37 is equal to x over 13. So here I'm going to have to multiply both sides by 13. So I have 13 cosine 37 gives me the value of x. Grab my handy dandy calculator. And I type in 13 cosine 37. Press enter. And I get 10.4. I could have used my sine. Sine would have been the sine of 53 degrees is equal to x over 13, and would have gotten the same value for that same problem. Looking at the next example. Here, they give me this angle here. This time I don't have the hypotenuse. I have my opposite and my adjacent. Since I have my opposite and adjacent, this time I'm going to be using the tangent. The tangent of 50 is equal to x over 11. So my goal is to get the x by itself, so I'm going to multiply both sides by 11. So I now punch into my calculator 11 tangent of 50 to find the value of x. So grabbing my handy dandy calculator here, I come over here and say 11 tangent of 50. I press enter, and I get 13.1. A half marathon. Now this last question here just says, what is the missing angle? I don't even need these things over here. All I need is my angle. This angle right here. Well, I know in a triangle has to add up to 180 degrees. Well, this thing right here tells me it's 90, so I can take away 90 right off the bat. And I know that the other two angles must add up to 90 degrees. So now, since I know one of my two angles, I know it's 36, I can go in and say, hey, take away 36 degrees. So I would borrow from this. That's 10, leaving a 4. This is now 8. 8 minus 3, that's 5. My missing angle here is 54 degrees. And I can now use either one, the sine or the cosine, depending on which one I prefer to solve for the value of x. When dealing with these, remember to always pay attention to what you're doing. Try and remember our triangles here. So we have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The tangent is the opposite over adjacent. And as always, good luck.